everybody. Welcome to this session. I'm really looking forward to speaking with you today, meeting with you, and interacting with you. My name's Emil Nusbaum. I'm the VP of Strategy, Government, and Regulatory Affairs with the Automotive Recyclers Association. I'm also very active in NatBat International, as well as I chair the State of Maryland's Commission on Lithium-Ion Battery Safety, and most recently starting to work with putting a coalition together as well for battery second life companies and reuse. But today in my topic discussion, which is going to talk about a lot of these different topics, is that this is called Powering the EV Loop: Trends, Challenges, and Opportunities. And what I want to do is kind of flesh out further what we heard in our keynote panel session about in terms of how are we going to secure the end of life or end of first life feedstock for battery materials to create a closed loop environment for battery materials that can help with our strategic goals in terms of critical minerals sourcing, as well as battery circularity and reducing the cost of new manufacturing for batteries and cell production in the US. So without further ado, I want to start with asking everyone a question. What are some of the elements for battery electric vehicle adoption and circularity? It's a two-pronged question, but I want to start with something to get everyone really engaged. Any takers?
Well, for BEV adoption, I would say probably, alleviating range anxiety, either through charging availability or bigger batteries, I guess, better batteries.
Definitely, Kathy. Good comment. Range anxiety. We're hearing that a lot from consumers that are, when they're shopping, do I want to switch from my internal combustion engine vehicle to my ICE vehicle, or no, my ICE vehicle to my EV or hybrid, or plug-in hybrid, we're thinking about range. Any other comments in terms of BEV adoption and or circularity?
Yeah, I mean, absolutely. I think one of the huge challenges we're seeing with automotive OEMs right now is cost, right? So even ICE vehicles, but especially in the EV market, we've seen a little bit of headwinds with the cost, right? So EV vehicles are typically more expensive, and then they come with their own issues like range anxiety, etc. And there's a bit of a learning curve too, right? So usually younger demographic is okay with learning the EV controls, but I think some of the maybe older generations are having trouble kind of learning some of the EV trends.
Yeah, Brandon, I really like that comment, especially one, obviously cost is going to be an enormous factor. We've had a lot of progress made in terms of reducing the cost of cells as well as battery packs and vehicles, especially when we're looking at different battery chemistries, which will help to drive down that price and make them more cost competitive with ICE vehicles as well. And then obviously we have our policy initiatives in terms of the new car tax credits as well as the used car ones that have helped to drive those prices and make them more competitive too. And obviously by seeing more scale, we are going to hopefully see an increase in EV adoption. One thing I really liked, Brandon, on that you mentioned that people I don't think talk probably about enough is just kind of the changing feelings or interaction you have in the car. And that may tie directly to a demographic element such as age, for instance. So I really like that. Good feedback. And then I'll take one more. And I see, Stephanie, you have your hand up.
Hi, Emil, thanks. I've actually got three. So one of them is I feel like education is still a really big one about education revolving around the technology and the fact that use cases for majority of the population in the United States, the amount of usage that's needed is a lot less than people really need. People think they need like 300 miles on a single charge when most of their driving is going to be significantly lower than that. And then the second one that I was going to mention was charging infrastructure. I took a trip to Northern California, and the Tesla supercharger network is much more mature than I think some of the other charging networks like ChargePoint or EVgo or something like that. But being able to plan out a road trip where you're not constantly having to go, okay, well, I'm going to have to stick to roads that have charging infrastructure available to me. And to that end, charge time, and that comes with battery technology. Just because, again, with respect to being able to plan road trips, having to allot the amount of time to, number one, find charging infrastructure around you, and then also allocating, okay, well, what am I going to do while I'm waiting for my battery to charge?
Yeah, Stephanie, I really like that. So charging accessibility, and then I'll also tie it in. It sounds like you're touching upon the reliability of the charging network as well. And
Yes.
that is something we've heard a lot in terms of different policy circles, as well as from the OEs. That's going to be a prerequisite. In terms of circularity, I want to just kind of start talking about that a little bit. Circularity, we have a lot of different issues that we're going to encounter. We touched upon some in that keynote panel in terms of how do you justify the cost of getting the battery out of that vehicle and having it be done so in kind of an economically viable manner. That's something that I think we're going to try to explore in this conversation as well. And so I'll move on to the next slide. So we covered a lot of the different ones in terms of BEV adoption. We have affordability, repairability ties directly into affordability over the lifetime of the vehicle. You have access to repair parts, lifespan of the vehicle itself, and it's got to be insurable. And then, as Stephanie mentioned, accessible and reliable charging infrastructure. In terms of circularity, we've got to have a commercially viable economy that allows for creating a closed loop reuse, recycling, and remanufacturing infrastructure. And even if you're just looking at the recycling infrastructure, we need to be able to do this in an economically viable manner that's going to incentivize the recovery of these batteries and their critical minerals. We obviously have some questions in terms of whether or not we even are going to get to the point where we're going to have sufficient refining capabilities, and then overcoming those challenges in terms of getting that new material going into new cell production. And then obviously mineral recovery, that goes beyond just recovery at a battery recycling facility, but we really need to start thinking about mineral recovery all the way from the moment that battery really leaves the factory in the vehicle and is now operating on the roads for a lifetime that could run from anywhere from a year or two to all the way to 12, 13, maybe even 15 years in some fringe cases. But this is something we need to be very cognizant of as we move forward. So moving on, what is automotive recycling? Just a show of hands, who's familiar with the automotive recycling and dismantling ecosystem? I know we have a few people on this call that are familiar, but I want to just kind of poll and get a bit of a understanding in terms of what our audience experience and exposure is. All right, we have Glenn. I see you have the thumbs up. All right, so we have some that are, some that aren't, but I'll kind of run it over very quickly. So as you can see on this diagram over here, we have this is a chart of ARA member facilities. We have about 1,100 member facilities we represent throughout the country. As you can see on the map, they're in every urban and rural area of the country. In many cases, our members are either a large Fortune 500 company like LKQ Corporation, or a more regional actor with multi-facilities, anywhere from 20 to 26 facilities. And there's a few of those in those types of companies. But then a lot of these facilities may be smaller regional actors and multi-generational family businesses. And when you think about that, don't necessarily think about it as a small player, because in many cases, a facility that may be qualify as a small business, but be a smaller player with only one or two facilities. For instance, our second vice president, he processes about 30,000 cars a year. And so he's actually dealing with a lot of volume, and that's going to kind of depend on the business model. So in terms of the industry, regulated in many different forms, both at a state and federal level, in terms of dealing with departments of motor vehicles, whether you're operating as a dealer, whether you're operating also as a scrap dealer, but as a auto dismantler. You have stormwater permitting, you have submitting titles to the National Motor Vehicle Title Information System, and then you have anti-theft measures that may be monitoring the sale of different reusable vehicle parts as well. But in terms of auto recycling, to really kind of sum it up, what our members are doing is they're being able, in a market-driven and a competitive environment, you have to be able to acquire vehicles. You're then depolluting those vehicles And then you're subsequently doing an analysis on the vehicle. Well, how many different parts am I able to sell to a collision repair shop or potentially directly to a retail owner? And that's really driving the economics behind automotive dismantling. And every year you have anywhere from 12 to 20 million vehicles that reach their end of life out of a population of about 300 million vehicles on the road that are registered. And as you can see here in this slide, only a small fraction of those are actually full electric vehicles right now. These are 2023 figures. The 2024 figures are not yet out yet, but we have approximately 4 to 4.5 million full electric vehicles on the road. So ultimately, in terms of how the automotive dismantling industry is looking at this, is we're having more and more EVs enter the roadway, as well as become available as candidates for entering kind of the salvage ecosystem and auto recycling ecosystem. And how do we prepare for that? There is going to be a lot of questions, and I'm going to raise those as we move on. But ultimately, that's going to be the crux of the context of where we currently stand. So I have a bit of a diagram up here. Some have seen this before, but essentially this is a very simplified diagram of what the end of vehicle life cycle looks like, where you may have a collision damaged vehicle that will enter an insurance auction, at which point it's bid on competitively by auto recyclers, vehicle rebuilders, used car dealers in some circumstances. You have a strong export market as well for the vehicles. This is especially true for electric vehicles. In one of our breakout sessions, there was an individual from Kosovo, and he was actually mentioning that countries in Eastern Europe, like Albania, as well as Ukraine, have 0% duties on imported electric vehicles. So you have a lot of EVs that are entering kind of the insurance salvage stream. They're actually making their way over to Eastern Europe. He mentioned that most of the taxi fleets are actually utilizing these types of vehicles out in Albania. So that's actually driving adoption there. But what's subsequently also happening is that this is causing leakage within the existing battery ecosystem for batteries that may be eligible for recycling and fueling a recycling ecosystem in and of themselves. And so ultimately, when you're thinking about auto recycling, it's trying to maximize the available use of components that can be reused or remanufactured, and then anything left over may end up at a auto shredder or scrap processor. And at that point, that will go primarily for the recovery of steel and aluminum that will go into new manufacturing. And so in addition, and then Chris, this is, I think, relevant to you, in addition to obviously trying to recover the minerals and the materials and the metals and the batteries, you're also now potentially running into an issue where, in terms of recyclable steel or candidates for recyclable steel, this may be getting lost as well through exports. But then also, to make the situation a little more complex too, is that some of the scrap processors and auto shredders actually won't even take a vehicle if it's an EV. They've actually had blanket policies where they won't touch these types of vehicles due to the liability and risks involved if a battery is going to go through an auto shredder, as well as they're not set up as part of their business model to actually be able to remove the battery from a vehicle. So this is going to have consequences as we start to see more and more EVs, especially ones that reach their end of life, as we start to make our way towards seeing more of these in the end of life vehicle ecosystem. So moving on, automotive recycling, it's a benefit economically, where vehicle owners, they have access to affordable repair parts. It reduces the lifetime ownership of the vehicle. So this ties into one of those elements that we discussed earlier, where electric vehicle adoption is going to be contingent on reducing the lifetime cost of ownership, whether or not that vehicle is going to be repairable, and then overall looking at the affordability of the vehicle. Auto recyclers, by utilizing existing resources and reusable parts, you have a competitive recycled parts market, so you have availability of these parts, especially as you start to see a vehicle get older. The average vehicle is 12.6 years old. As that vehicle gets older, in many cases, the OEM doesn't actually manufacture new parts for that vehicle or have them in inventory, or they're not accessible from a cost standpoint. In terms of reducing carbon emissions, it reduces the need for new manufacturing. So moving on to some of the direct challenges when dealing with an EV, some of the things that need to be paid attention to is, one, there's a very high cost to acquire electric vehicles at some of these salvage auctions, which is the primary way of acquiring end-of-life feedstock. So I have over here on the side, and this is a good example, and I have another one coming up, but this chart are vehicles that were at one of the major salvage auctions, and these were all vehicles that were listed for auction 3 weeks after Hurricane Milton. And as you can see from some of the values and bids on these, you have bids from all the way from $22,000 to $12,000 to acquire that vehicle. And the big mystery is, can you earn anything on the battery? Is there any value to be had in the battery, which is going to be one of the most valuable parts that's driving the overall value of that vehicle? And so one, we need to figure out in terms of what the market is for end of life and end of first life batteries, because right now we have a relatively immature market, especially for reuse, remanufacturing, and repurposing, which are going to be the primary outlets in terms of deriving meaningful value for that type of battery coming out of a vehicle. You also have a problem where certain parties are actually leaving the market. So in terms of a core buyer, these are companies that are kind of intermediary middlemen that will come to your facility. They'll collect batteries in many cases, at which point, as a result, because they'll have a larger amount of volume, which allows them to actually be able to find economic value because they're operating at more scale in terms of having that. But they're leaving the market and no longer maybe interacting with certain batteries or battery types, which makes it more challenging to justify an auto recycler to actually engage with these types of vehicles. You also have a tremendous cost in many cases in terms of outfitting your facility and getting your facility ready to deal with these high voltage vehicles. You need new tools, you need new equipment, you have to train your employees, you may have to build new infrastructure for dealing with these vehicles. And taken within the context of you already have a very profitable business model for internal combustion engine vehicles, this makes the incentive structure in terms of starting to interact with EVs all the more challenging. And these are things that our members are currently trying to work on, as well as ARA, in terms of trying to push our members forward so that they can take advantage of some of the opportunities that exist when dealing with electric vehicles. So I have up here too, in terms of EVs. So this was a recent article by Kelly Blueborough, which basically says that EVs are more costly to repair. Now, why is that? Well, one of the reasons is there tend to be newer vehicles, as well as you have limitations within the independent collision repair market, where some of the major collision repairers actually won't touch EVs. They won't, as a blanket policy, they won't interact with them because they've had certain safety issues. They don't have best operating practices in line. And so they're still trying to figure it out. But this is raising the costs in terms of repairability. In terms of battery replacements, you have limited battery replacements. So you're really kind of at the mercy of the OEM at this point in terms of sourcing a battery replacement if you would need one. And as you can see on this diagram, that is data from CCC, which is one of the major collision estimators, you have that in 92.7%, the parts utilization is almost exclusively new OEM parts, as opposed to any aftermarket or recycled or refurbished markets as well. So these are all immature markets, but at the same time, this presents an opportunity moving forward, but is something we need to be cognizant of as we move forward, especially when we're thinking from the goals of trying to create more EV adoption and get more people driving EVs as time goes on. So battery recycling. This is one of the challenges that really is going to be a driving factor as to whether or not automotive recyclers are really going to be able to even start engaging with these vehicles in the first place. These are numbers and quotes that were actually provided by a major battery recycler about last week from one of our members. And the numbers were very shocking to both the member with these batteries in possession, as well as to many of ARA leadership. So unfortunately, what you see here is some of the challenges where if you only have an option to recycle these batteries, you may not be able to even interact or deal with these vehicles at all because of the high cost in terms of actually getting rid of the batteries if you don't have a viable reuse or repurposing market. So what you can see here is that first things first, chemistry certainly matters. So in terms of the first two examples, you have Ford Mustang Mach-E batteries and their LFP chemistries, they're 1,300-pound batteries, and you'll have to pay the battery recycler, according to these quotes that were offered, you'd have to pay them $1,300, and this doesn't even take shipping and transport into account. So this raises a very serious question in terms of If batteries are going to be a single-use item, at which point every battery coming out of a vehicle more or less needs to go straight to recycling and is truly end of life, are we now just dealing with waste as opposed to dealing with a recyclable commodity potentially? These are questions that we need to be asking right now. We need to be thinking about in terms of the policy environment. But even as we start to look down the line here, when you look at the NMC batteries, which you would assume, all right, you have valuable commodities in those batteries, there should be enough value that will fuel a successful recycling infrastructure similar to what we see with internal combustion engine vehicles in terms of the reclamation of platinum, palladium, rhodium, steel, and aluminum. Unfortunately, it's not looking nearly as enticing from an economic standpoint. So even with this Ford Focus BEV, for instance, 727-pound battery, that's NMC, your scrap value or your recycled metals value that you would be seeking to get is only $82. So very insubstantial, especially when you're not even taking into account transportation costs. And it's also worth noting that all these batteries are being considered non-DDR batteries, but we're dealing with a population of batteries that may have been involved in a collision in a vehicle, at which point there's going to be a vast majority of these, which probably will be DDR, which will actually increase the transportation costs. So unfortunately, what we see here is an example where every single one of these batteries to an auto recycler that's dealing with these batteries, trying to find the maximum amount of value, they're all negative value. At which point we have to start asking ourselves, how do we then start to work where we can utilize existing end-of-life vehicle recycling infrastructure in order to make sure that we can still meet our goals of fueling a closed-loop system, promoting battery recycling and recovery of these materials, and also minimizing the potential for stranded batteries as well. That could put pressure on state jurisdictions in terms of handling them if they're going to end up potentially being stranded in certain locations. So this is just a diagram. It's a highest and best use diagram, which kind of goes into a potential outlet or a potential way for batteries once they reach their end of first life in terms of being able to maximize that value as well as maximizing their existing useful life, which has a positive environmental benefit. So this is something we put together with the Argonne National Laboratory, and this is really kind of served as the basis for what the automotive dismantling market already looks like, as well as the business model, but also saying, how do we incentivize the collection of batteries that have reached their end of life or end of first life or out in the market, and then make sure that they're going to be handled responsibly. So we look at reuse in a vehicle. We have members that are already starting to do this, but at the same time, we aren't sure whether or not there's going to be enough scale or availability to be able to do this long term. Especially one of the challenges that needs to be overcome is how are insurers looking at the repairability of these vehicles? They still are very much in a position of a wait and see approach in terms of how are we going to fix these types of vehicles? What types of parts can we use in repairs? And that's something that's still being looked at right now. But due to the fact that many of these vehicles are still relatively new relative to the general vehicle population, that is something that is going to come to the limelight in the coming years, especially as insurance total loss rates have increased in the past 5 years, and then also insurance premiums have increased. Repaired or reconditioned, can the battery be repaired or reconditioned to go back into vehicle function? Or does the battery have a potential second life in a repurposing system, whether that's a BESS energy storage system or some other energy storage? And finally, then recycling. Is the battery truly at an end-of-life state where the only thing you can do with it is going to be recycle it for its commodity value, or alternatively just recycled in the case of LFP? Is it just going to have to go to get recycled because there's no other viable outlet for it? So regulatory considerations, Kathy, I know you're on the call, but one of the things that we're looking at, especially as we've worked amongst various jurisdictions, there's been a lot of confusion in terms of how do you qualify and how do you actually put a condition on these batteries in terms of when they're coming out of the vehicle. We actually heard, talking to other jurisdictions, that their Department of Environment agencies were saying that any battery that comes out of a vehicle needs to be classified as a waste. Now, we're much more preferential in terms of the EPA's FAQ, which essentially says if there's a rational basis or really a reasonable or strong case that it can be reused, it's not a waste yet. But at the same time, we need to be able to actually better evaluate these batteries coming out of a vehicle through testing as well as diagnostics to understand Is it a waste because it needs to go straight to recycling, or alternatively, does the battery itself, what are we looking at on a condition basis? Because right now there's very limited visibility, especially for our members removing a battery, as to whether or not it's in a safe operating condition or it's not. And that's going to have a determination as to whether or not we're dealing with a waste and whether it's special care or handling processes for transportation need to be taken into account, especially storage. So ARA over the last couple of years has really been helping the industry get ready for EVs. We have training and certification. We've assisted Argonne National Laboratory on a survey in terms of saying where the auto recycling industry is in terms of training and being ready to process these vehicles. And we also make our electric and hybrid vehicle technology guide, which is essentially a basis for our training. We make that publicly available and also publicly accessible to the industry. We've been very active with the DOE, LiBridge, NatBat, and NEMA as well. Someone had mentioned the traceability standard. We've been very actively engaged with SAE's traceability standard as well. So in terms of some best practices, I just want to run through them real quick. So electric shock, fire, explosion, but I also want to leave some time for discussion. So any questions?
Yeah, can I ask a question?
Yep.
Is there is there a possibility to make some sort of a marketplace to trade uh, batteries, spent batteries, and so on, and some sort of a centralized marketplace or some sort of a exchange or something?
So
Thank
it's a
you.
really good question. And then is it Raghav? Yeah, so Raghav, good question. So right now, in terms of, I think it's important to look at, what types of markets exist. There are a couple specialized battery markets. There's Circonomics, I believe, that's operating in Europe primarily. There's also Currents Marketplace in the US. There is several, so I think there's several specialty marketplaces that are just focused on vehicle batteries. However, what is very interesting to think about this is that in addition to those marketplaces, there are already the existing marketplaces for vehicle components. So you have eBay, for instance. You can go to eBay and actually find either modules or full battery packs listed on those markets. And then there are also specialty markets for recycled auto parts, such as car-part.com, which, for instance, will have a large inventory of potential battery candidates if you were looking to acquire some of those batteries, whether you're a battery recycler, you're a repurposer, you're a remanufacturer. So there are many different outlets and different options. In terms of how auto recyclers are looking at it, it's interesting from the standpoint of they usually are very prone to using the existing ecosystem that they're used to using for their other components. So when you're looking at car-part, which operates seamlessly with their inventory management systems, they're probably more preferential to those. But I know that many are utilizing those specialty markets as well. But the question in terms of those marketplaces is how many potential buyers do you have, at least at this moment, because it's still somewhat of an immature industry.
I have a quick question when it comes to the let's say when it comes to battery recycling. So we all know that when the batteries, let's say, if you're a cell manufacturer or if you're a vehicle manufacturer, OEM, and then when the it's critical for them to think about that if they want to go into the battery recycling market and put together some investments, they want to make sure that they can get the end of life batteries back from the end customers. So we know that this is going to be crucial, and the capacity is the key over here. So if you were the cell manufacturer or the OEMs, let's say, what options would you recommend, or do you think they have in order to secure those those end of life batteries from the customers that they don't have ownership with anymore?
Eddie, that's a really good question. And I think there's many different factors at play. I can't go ahead and speak on behalf of the OEMs, but I can at least kind of, we can brainstorm some things with regards to that. First off, my fear is that we've been hearing a lot that the market itself is going to drive the collection of these batteries and get them to battery recyclers. Unfortunately, as it currently stands, especially looking at some of those quotes from the battery recycler, is that I don't necessarily see that to be the case, especially in the short term. In terms of the auto dismantling industry, you already have a very profitable model dealing with ICE engine vehicles, and the population of EVs is relatively low. So why would you go away from your core competency where there is a profit to be had on those valuable components versus now exploring EVs where you may actually have to outlay a significant amount of money in terms of just getting rid of the battery to make sure it's responsibly processed? I was on a webinar the other day, and one of the people that was with the agency I was talking to basically said they're worried that this could potentially become similar to used tires, where used tires essentially are a cost to dealing with, and this is very similar, other than you have fire risks associated, electrical shock associated. They're also significantly heavier than used tires, and subsequently, the cost of actually getting them processed is significantly higher than used tires. In terms of an OEM thinking about it on a policy basis, you have a couple options. Does this mean that we're going to have an EPR framework set up in terms of dealing with those batteries that are of negative value that an entity can't afford to be able to get rid of? That's one option. You also have potentially, do we need to look at lead acid? Everyone likes to talk about lead acid because it's been so successful in recovering those batteries and making sure that they actually are recycled or reused adequately, and that's due to a core deposit program. So do we need a core deposit program? Is that something that the OEs would be open to? Not sure. So, but that's another thing as well to think about if we're thinking, how do we secure that material supply? Because obviously the OEs are looking for feedstock or recycled materials to go into new manufacturing. Now, would this potentially even change with the current legislative environment too, where the Trump administration is looking to get rid of a lot of the clean energy tax credits? So would that pull back some of the eagerness of the OEs in terms of actually being or wanting to seize these materials? I'm not sure, but that's going to have a significant effect on, I think, their disposition moving forward. But those are all really good observations. It's a good question. And there are a lot of different factors when evaluating, what necessarily makes the most sense, both economically from an OE standpoint, but also making sure that we can have a circular and clean economy surrounding dealing with end-of-life batteries. I mean, are we dealing with a recyclable commodity, or are we just dealing with a waste? I mean, that's one of the big ones as well. And I think harmonizing some of those waste regulations around a federal framework will be very useful, especially for giving more clarity as well as predictability on all the actors who are dealing with end of life and end of first life batteries.
Yeah, absolutely. Thanks for the insights. I think that we're all facing, from the OEM standpoint, we're all facing the certainties on the regulation side. We know that EU already have something in place that moves the ball forward quickly. But in the United States, at least, it's still it's up in the air right now. It's at the moment, we all know the direction, but we don't know how soon it's relatively coming. But also we know that, basically, if that's going to be let's say a strategic direction that, let's say as an OEM or manufacturer wants to get in, and then want to basically make sure that there is a business case that would, justify the investment. And then that comes to my question that, if I sell a car already into the customer hands, how can I make sure that I can get the batteries back? And if so, what is the cost for me to do that, and how does that impact my business case? So I think that's a question that I know that we're asking ourselves.
Yeah, and that's you make an interesting question where if you want to close the loop by having the OE essentially have control of that battery throughout its whole life cycle, you then probably have to fundamentally change the very principle of vehicle ownership itself, where you're dealing maybe on a subscription basis, which some of the OEs have tried, as opposed to being selling the vehicle wholly, with full title to a vehicle owner, at which point you have no control over that vehicle as it moves throughout the value chain.
Right.
And then whether or not potentially even in terms of an auto dismantling and recovery of those end-of-life batteries, you potentially may even run into the question, if you're an OE, well, it may be the case where if we're so desperate to get these materials into a closed loop or to potentially mitigate liability in terms of what happens to the battery at end of life, do you then have to go to the open market and potentially now acquire those batteries yourself from some of these salvaged vehicles moving through the ecosystem, and then potentially have to pay a third-party individual or organization to then process those vehicles and get the battery out? That's a possibility too. I know that many of our members actually have direct contracts with some of the OEs, and what I'm assuming is they're getting some of these vehicles that are under that total OE control, and they're having to do it on a service contract and have to pay for the dismantling up front. And that's something that may end up happening more and more as we start to see more volumes as well.
Yeah, absolutely. That's definitely an option to think about. Yep. Thank you. Thanks for the insights.
I think we have time for, I know we're a little over, but does anyone have any additional comments, impressions, or anything to contribute? All right. One thing, Eddie, that actually, let me take one step back. A final comment in terms of, right, we've talked about the policy environment, both Europe and the US. And one thing that we've started to see in Europe, at least have heard firsthand from one or two of our larger members who deal with tens of thousands of vehicles a year, is that right now they have an oversupply of end-of-life batteries, but they don't have anywhere to actually send the batteries. And that's due to the relative immaturity of some of the battery recycling in Europe, but also due to the fact that they have not fully developed some of their EPR frameworks when the OEs do have a legal obligation to take the batteries back, because of some of the significant costs associated with actually recycling those batteries. But other than that, this has been a real pleasure. I've enjoyed the conversation with everybody, and you have my contact information, so feel free to reach out to me if you have any further questions or want to collaborate. And I thank you very much.
Thanks a lot.